Initially, it might not be obvious that Pythagoras' theorem can be used to help solve a particular problem. However, with further investigation, it may be possible to identify and draw a right-angled triangle which can help solve a problem. As long as two sides of the right-angled triangle are known, Pythagoras' theorem can be used to calculate the length of the other side. In this video, we'll look at three-dimensional problems where Pythagoras' theorem can be used to solve them. Remember, when solving problems using Pythagoras' theorem, we can follow a few steps to help us solve the problem. The first step, identify and draw the right-angled triangle which may help solve the problem. Second step, label the sides with their lengths or with a letter if the length is unknown. Use Pythagoras' theorem to solve for the unknown, and then solve the problem with any further calculation or answering in words. Here we have an example. For the rectangular prism below, find the length of DE. Give your answer in exact surd form. It's important to try to draw any of the identified right-angled triangles using a separate diagram first. In this example, we can't find the answer of DE straight away because we don't know the answer for GD. So we've got to find GD first. So we draw the triangle CGD, which is on the base of the rectangular prism, and then we can solve for GD first. So we write CG squared plus CD squared equals GD squared. So we know CG and CD, so we replace them with 2 and 4 respectively. So we get 2 squared plus 4 squared equals GD squared. And then we can solve 4 plus 16 equals GD squared. And then we get GD squared equals 20, and we square root both sides, and we get GD is equal to the square root of 20 meters. Now we're finding our answer in exact surd form, so we're going to leave the length of GD in surd form. Now we can find the length of DE, which is what the question is asking for. So we draw the triangle GED, and we write out Pythagoras' theorem, which is GD squared plus EG squared equals DE squared. And this time we sub in the solution from the previous triangle, so we get the square root of 20 squared plus 6 squared equals DE squared, and that simplifies to 20 plus 36 equals DE squared, and then we get 56 equals DE squared, and DE equals the square root of 56 meters. Now, with worded problems, we write our answer in sentence form. We write the length of DE is the square root of 56 meters. A 15 centimeter drinking straw sits diagonally in a glass of radius 3 centimeters and a height of 10 centimeters. What length of straw protrudes from the glass? So you might be able to identify that if we looked at the glass side on, the straw forms a right-angled triangle with the glass. So first of all, we draw a right-angled triangle and label the diagram. So we're trying to find the length of the straw that's inside the glass because we know the dimensions of the glass. In this example, we're given the radius of the glass, but we need the diameter, so we've got to double it to make it 6 centimeters. And we can use Pythagoras' theorem to find the length of the straw inside the glass. So we write 10 squared plus 6 squared equals x squared, because x is the hypotenuse on the triangle we've drawn on the glass. Then we go 100 plus 36 equals x squared. And we get 136 equals x squared. We square root both sides, and we get x equals the square root of 136. Therefore, x equals 11.66 centimeters. Now, don't forget that's the length of the straw inside the glass. The question's asked what length of straw protrudes from the glass. So we're not finished yet. We need to do 15 take 11.66. That equals 3.34 centimeters. Because it's a problem, we write our solution in sentence form. We get 3.34 centimeters of straw protrudes from the glass. A water tank can only be accessed from one side to be clean. What is the minimum length hose that will be required to pump the sludge from the other side of the tank? The diameter of the tank is 3 meters and the height is 2 meters. So here we have our water tank. If you look at it from side on, you'll notice that we can draw a right-angled triangle to work out how long the hose would have to be to reach from one side to the bottom on the other side. We label our diagram. In this case, we've labelled the hypotenuse for the triangle H for hose, and we can use Pythagoras Theorem to solve for the length of the hose. We write 2 squared plus 3 squared equals H squared. No, we get 4 plus 9 equals H squared. We get 13 equals H squared. And we get H is the square root of 13 meters. In other words, H is 3.61 meters. The minimum length of hose is 3.61 meters in order to pump the sludge from the other side of the tank. A diagonal pole on this tent was lost and needs to be replaced. What length replacement pole is required? The height and base of the tent measure 200 centimeters. So we need to draw our right angled triangle onto our diagram here and then label it. So as you can see, the height of the tent is 200 centimeters and the base is 200 centimeters. And together we can use that to find the length of the diagonal pole. As you can see, the base of the triangle was 200 because we're only looking at half of the base. We need to halve it to 100 centimeters. So we get 100 centimeters plus 200 centimeters. 100 centimeters squared plus 200 centimeters squared equals d squared, which is the diagonal. And therefore, 10,000 plus 40,000 equals d squared. And we get 50,000 equals d squared equals 50,000. Square root both sides, and we get d equals the square root of 50,000 centimeters. And we get d is 223.61 centimeters. We write our answer in sentence form. We go, a 223.61 centimeter replacement pole is required. Thank you.